everyone, so this video is about covalent bonding. So last time we looked at ionic bonding, which we said was between a metal and a non-metal. Well, what happens when two non-metals bond together? Well, this is where the idea of covalent bonding comes up. Okay, so these are bonds which make up the vast majority of compounds in our body. Okay, and it's formed when these atoms share pairs of electrons. Okay, so again, why are we learning this? So these 2 points are the same as the ionic ones. So we need to understand bonding to be able to understand the various chemical and physical properties of an element. And again, without chemical bonds, nothing would exist, and even we wouldn't exist. Okay, so we're going to be able to state what a covalent bond is. We're going to describe which elements form covalent bonds and be able to draw dot and cross diagrams of this. Okay, so similar recap questions to last time. I'm just going to give you some time now. So if you pause the video, 10 minutes, off you go. Okay, and here's your answer again, drawing your attention to 8. Okay, so knowing the masses and the charges of each of these subatomic particles. Okay, so we're thinking about covalent bonds then. So we're talking about non-metals. Now, if you remember on your periodic table, if you draw a staircase down this side of the periodic table, that shows you where the non-metals are. Okay, so when non-metals react together, neither of them can give away electrons. So instead, they share pairs, and that allows each atom to have a noble gas configuration. Again, we're looking at the idea that the atoms want to have a structure similar to that in group 0, okay, a full outer shell. So if we have a look here, covalent bonds can be single bonds, which you can see here. Okay, so we've got a shared pair of electrons. So hydrogen has one electron on its outer shell, and they share to form that full outer shell. Okay, we can have a double covalent bond right here. So oxygen has 6 electrons on its outer shell. So that means it needs to gain 2 more, okay, to have a full outer shell. So if we look here, that's happened, giving us a double bond. Okay, and finally, we've got a triple bond here. Okay, so I'm sure no prizes for guessing that that's between 3 electrons on both atoms. So in total, there's 6 electrons involved. Okay, so if we look here, this is where things get a little bit more tricky. For example, we've got water and we've also got methane. Now we can see that oxygen here requires 2 hydrogens. So that's why we get H2O, okay, because it's requiring 2 electrons. Hydrogen only has 1 electron in its outer shell. So therefore, to get the full outer shell, it needs 2 hydrogens. Okay, methane, we've got the carbon, and then that requires 4 hydrogens because carbon's got 4 electrons on its outer shell. Hydrogen's only got 1, and they all need to share. Okay, so we need to form this bond here. Okay, so a couple of comprehension questions this time. It's a really short video, this one. So explain what a covalent bond is, okay, and how many electrons make up a triple bond. Okay, so a covalent bond is a strong bond between 2 non-metals. It's the sharing of electrons as neither donates or receives electrons, okay, they only share. How many electrons make up a triple bond? So 6 electrons in total make up a triple bond. If you remember, it's 3 from one atom and 3 from the other. Okay, so draw diagrams to show all of the covalent bonds in these molecules. So we've got chlorine, water, and ammonia. So look really carefully at the numbers that follow. So we've got chlorine, so we've got Cl2. So that tells us there's 2 atoms of chlorine. We've got water, we've got H2O. So that's telling us that there's 2 atoms of hydrogen. And then we've got NH3. So that's telling us that there's 3 atoms of hydrogen there. Okay, so here we go. So we've got chlorine. Again, we talked about this last time, but we've got dots and crosses to show that they're different electrons from a different atom. Okay, so we've got the overlap here. So hydrogen and oxygen. Okay, and then we've got methane. Okay, so that's the end of today's video. Obviously, there might be a little bit more that you need to have a look at in further detail. And you can use the bite-sized resources for that, or you can use Educake.